So we're going to do the point slope form of a straight line. And that's just saying that the point slope is y minus y1 is equal to mx minus x1. Okay, you either know the slope, right, you're given, or you can determine if I've got 2 points, that gives me the slope. I need 2 points for the slope. So I'm either going to have to be given the slope or I'm going to have to find it. And that's two versions of this very same thing. And if I'm given it, then all I need is m and the point x1, y1. So if I know that, I'm kind of using this same version and multiplying both sides by that, and then saying the second point is doesn't really matter, it's any point x, and then that gives me the y minus y1 is mx minus x1, and that basically comes from that. Okay, all I'm kind of doing is solving, so multiplying both sides. And that gives me this, and then I'm just taking my x2 as any point, my y2 is any point, and I'm just saying those are just my y. Okay, so use the point slope formula to write an equation of the line having the given conditions. Write the answer in slope intercept form if possible. Passes through -4, 2, and m is equal to 2. Okay, so through, I'm going to say y minus y1, m, x minus x1. Okay, so I'm given that m is equal to 2, and it goes through -4, 2, goes through that point. So I just want to put these things in here. Here's my x1, here's my y1. So my y1 is going there, my x1 is going there, there's my slope, and then I just write it. Okay, so y minus 2, slope is 2, x minus my -4. Okay. So my y minus 2, 2x plus 4, and if that's all I'm asked for is the point slope, then that's all I'm given, but it's saying write the answer, so go from there to the slope intercept. So that's what they need. Okay. So once I do that, all I'm going to do is take this and solve. So I'm going to distribute just like if I was solving, but I need to solve for a y, and then I'll finish it up. So y minus 2, distribute, 2x plus 8, 2 times my 4, and then my plus 2, so y is equal to 2x plus 10. And again, I can use my functional notation. The function, f is a function of x, y is a function of x. Give me the value and I will tell you the value. So give me x and I will calculate what my y is. Okay. So use the point slope formula to write an equation of the line having the given conditions. Write the answer in slope intercept if possible. So passes through 5, 0, and m is equal to -2/3. So I'm going to start out with my point slope form, and that is y minus y1 is my m x minus x1. M is equal to -2/3, and my point that's going through is 5, 0. Okay, so I'm going to do, here's my x1, here's my y1, so my y minus 0 is equal to -2/3 for my m, x minus 5. So y is equal to -2/3 x, because we're going to go, this is -2/3 x minus 5. That's the point slope form, but we want it in the slope intercept. I'm just going to distribute. plus negative, and then that would be the 10/3. Okay. So I'm going to give you an alternate version that I kind of prefer, and that's just going directly, since it's asked for me in the slope-intercept form anyway. I know the slope-intercept form is this. I know one of the points, so it has to satisfy y is equal to mx plus b. So it has to, this point has to be a solution. So here's my negative 2/3. My x is 5 plus b, and that's what I'm solving for this time. And then here is just 0 is equal to minus 10/3 plus b. I want b by itself, so this goes over here, and my 10/3 is equal to my b. So then I just finish it up. Y is equal to minus 2/3 x plus 10/3. I somewhat prefer this method over going through the point slope and then following it up with this, but that's generally the way it's taught, is do this. But later on, we'll have a chance to use this, and then this methodology of saying this has got to solve to find, and then having to find a particular value like that, we're going to use that several times as we go forward. So use the point slope formula to find an equation of the line passing through the point -5, 2, and having slope -3, and then write the answer in slope-intercept form again. Okay, so let's do y minus y1, mx minus x1. We're given m is equal to -3. Y minus y1 is our 2. -3 x minus -5. I want to make sure I put that in parentheses because this needs to subtract, and that's going to change that. Okay, so y minus 2, -3 x plus 5. And then I'm going to distribute. Minus 3x minus 15. And then getting it into, so now I'm going to slope-intercept, plus 2, plus 2. And then I just group and simplify. Like that. So use the point slope formula to write an equation of the line having the given conditions. Write the answer in slope-intercept form. So here kind of puts everything together. I've got 2 points. 2 points is all I need to determine a straight line. Give me the 2 points, right? Here's 2 points that has a straight line between them. Okay, and it's the same thing if we're doing analytic geometry. Geometry on our Cartesian coordinates, so that's what we're doing. Okay. Here we're not given the m, so m, I don't know. I'm just given the 2 points, -1, -4. So it passes through these 2 points, passes through those 2 points. So left to right, this is my first one, so I'm going negative bigger. So this is going to be my point 1, point 2. I just want to get my, set everything up in terms of x1, y1. So my point 1, this is my x1, y1. Here's my point 2, x2, y2. Not given the slope, so I have to determine that. So I have to use my slope formula. y2 minus y1, x2 minus x1. And then I just use my points. Okay, so my slope is my y2, -4, minus 1, x2, -1, minus a minus 2 for my x1. minus 5, negative 1 plus 2 is plus 1, so that's negative 5. Okay. And from here, as I moved over 1, I dropped down from plus 1 to negative 4 going down. So that's that slope. Okay. So next step, then we're going to use the point slope. Okay. So I'll get to choose whichever one I want to use, but I want to do a y minus y1, mx minus x1. Either one I can choose, but I need to stick with the same thing. So let's do this one. Y minus 1, that was my y2, this is my y1, sorry. And m, that was negative 5, x minus a minus 2. So y minus 1 is equal to negative 5x plus 2. So if all I needed was the point slope, that's it. That's the point slope form right there. Okay, but we want to go to the slope intercept form. So I want to take this, let me kind of write this over here, y minus 1, negative 5x plus 2. And I'm going to slide. Okay. So I'm going to distribute over here. And then plus 1 over there, plus 1, which gives me the y is equal to minus 5x minus 9. So we were started out, we were given 2 points. We want to use the point slope formula. So I do the slope, I find the slope first, put them into the point slope, and then do the slope intercept. Once I know the slope, I could also have done, here's my y is equal to mx plus b, so I know the negative 5 plus b, but I don't know the intercept. So I'm just going to pick a point. Let's pick any point. Okay. Just from here, right? Because I knew the slope. Here's the slope intercept. So I'm going to do the negative 2 is equal to minus 5, 1 is equal to minus 5 times negative 2 plus b. And then I subtract a 9 from both sides, and I get that my negative 9 is equal to my b. I was thinking ahead too far. Okay, which gives us the very same thing that if I finish this up, my minus 5x minus 9. So this method was through the point intercept, doing distribute and continuing out. And here was, I knew what the slope was. So from the slope, I know that I wanted the slope intercept. I don't know what the intercept is. I just solve for the intercept and then rewrite it. Okay. So here's just a couple of special cases that you just need to kind of recognize. So use the point slope formula to write an equation of the line having the given conditions. Write the answer in slope intercept point if possible. Passes through 2, 3, and the slope is undefined. So the undefined, so here's my x, y. A vertical line. M is undefined. Okay, so that's what it says. It says undefined, but it passes through, x is 2, so let's kind of use this very same thing. It would be like 2, 3. Okay, so all along this line, so it's a vertical line. I know what the x is at a particular point. All along that thing, x is the very same thing. X is 2 down here, x is 2 here. This would be like 2, negative 3, but that's the equation of a line where it's undefined, the slope is undefined, and that would mean it's a vertical line. Okay, so you went from undefined, it has to be a vertical line, that's the only place that a slope is undefined, and then I just pick this out, plot a point, and I realize that it's a vertical line going through there. The only thing that's not changing along that vertical line is the x value. So that is the equation of the line. Okay. And it says use the point slope formula. So let's do this. Y minus 3 is equal to but see, I can't use this because the m is undefined. Okay, that's why we have to go directly through and say here the slope is undefined, that means it's a vertical line. I can't use this. Okay, so I just got to write the equation. Okay, write an equation of the line passing through those points. Here I'm free to use whatever method I would like. Okay, and if I'm going to do that, I would go directly to the slope intercept. So between here and 7, -3, okay, I'm going to do left to right. This would be 0.1 because this is further to the right. So this would be my 0.1. This would be my 0.2, my x1, y1, x2, y2. Okay, so I need my slope. y2 minus y1, x2 minus x1, -3 minus 5, 7 minus 2. So that would be my m, -8/5. And then I would, if this was just me, I would go directly to the slope intercept. Okay. And then all I need to do is just pick any point, which either easiest to use. Let's go with this one. So my y is 5, my slope is -8/5. 2 is my x plus b, and then I just simplify out. Okay. So 5 minus 16/5 plus b over here, so take this over there, plus 16/5 for both sides. And this is 5 plus 16/5, 25 plus 16/5. And that's my b. So now I can just finish it out. Y is equal to my -8/5 plus 41/5. So if I'm free to choose, this is the method I go with. And like I said, there's just many other applications of this, of picking a point and then solving for some unknowns later on. So this is kind of what I preach early on. So you've seen it before several times once we get there. Okay. So special cases are parallel and perpendicular lines. So in general, I've got parallel lines. So here's parallel lines. I'm going to call it L1 and L2. Okay. So if I put this on the coordinate system, then I can define the slope, right? This is L2. So this now has slope M2. I want to call it M2. This has slope M1. And here's the notation from geometry. L1 is parallel to L2. That's what these two lines mean. Okay, so they're never going to cross. They don't cross. Ever. Okay. And if this is the case, it turns out that the slopes are equal. M1 is going to be equal to M2. So if I know the slope of 1, I can say if you want them parallel, the slope's going to be different, but you got to tell me what point this thing goes through, because there's an infinite number of lines that are parallel to the other. Okay, when I've got two parallel lines. Okay, so this kind of, you give me one, that's going to determine, and then I need a point. So once I've got a slope, I need a point to and then I can write my slope intercept. Okay. So that's the parallel lines. Let's say if I have two lines, I'm going to do this, and hopefully I'm going to do a good job of this. This is L1, here's L2, and this little angle in here is a right angle, which means 90 degrees. Okay, so that's the floor and the wall. Hopefully it's a good perpendicular wall. You walk up to it and that, everything is straight up and straight down. Okay, but now I'm going to put it into a coordinate system. Here's X. Here's my Y coordinate system. Okay, so then I can say, well, this L1 has some slope M1. Okay, this L2 line has some slope M2. And if they are perpendicular, and this is how I use the perpendicular notation from geometry, if L1 is perpendicular to L2, then the second one, if I know the first one and it works either way, it is just the negative reciprocal of the first one. Okay, so if this one is increasing, this one's decreasing. That's why the negative sign. Okay, this is positive, this one's going to be negative. And if this is negative, if I do the exact opposite, that's negative, that's going to be the positive slope. Okay. So we're going to use a couple of these facts and then be able to write lines that, to whatever we want to do. So we may know some surface, we write the equation of a surface, and then I need another line or something perpendicular to it. Okay. So parallel lines have matching slopes. If M1 and M2 represent the slopes of two non-vertical parallel lines, why non-vertical? If they're vertical, then their slope is undetermined. Okay. Perpendicular lines have slopes that are negative reciprocals. If M1 and M2 represent the slopes of two non-vertical perpendicular lines, then M1 is equal to -1 over M2, or M2 is equal to -1 over M1. These are interchangeable, and it comes up with the same relationship, that negative reciprocal. Okay. So here we're going to get started out. Here's a couple of examples. So M is equal to -3/8, and it wants, give me the slope of a line parallel and perpendicular. So the slope only is what I'm looking for. So if you want a parallel slope, well, it's the very same. Okay, so the parallel slope would be the very same thing. No matter what this is, the one parallel to that is going to be -3/8. So that would be decreasing -3/8, another one -3/8. If I do a perpendicular line, I'm going to use a slope of -1 over -3/8. Okay, fraction, this is -1 over 1, invert, and multiply the bottom. I always start with the bottom and then use that to give me the form of what that top needs to be. So this is -1 over 1 times 8 over -3. That gives you a positive 8/3. Negative the reciprocal. So here it's given us M is equal to 20. So if I want the parallel slope, I'm going to use that symbol just to save me some writing. Then M2 is equal to 20. Let's say if this was M1. Okay. Now if I want a perpendicular, -1 over 20. It's the negative reciprocal. Negative 1 over m1. m1 is equal to m2. That's what I'm doing. Okay. So finally, it gives me this tricky one. Here's m is equal to 0. If I want parallel, the slope is going to be equal to 0. So this is basically saying anytime I need a parallel line and the slope is equal to 0, it's going to be parallel to the x-axis. So here's another line, m is equal to 0. It's always going to be parallel to whatever that one is. Okay, and then the perpendicular, I've got to have something here. So here, the equation would be y is equal to something, let's say 2. This one would be x is equal to, let's say 3. That would be perpendicular, but, you know, it's all along that line. So as we step up, we're just going to basically build upon what we know. So we went through these exercises. Now we're just, this is the end game, right? We're going to give, here's one equation, and then I want an equation of line either perpendicular or parallel to that one, but it needs to go through particular points, okay? Okay, so given the equation of a line, needs to pass through negative 1, 2, and is parallel to y minus 3x is equal to 4. Okay. So I know for parallel lines, m1 is equal to m2, but what is my other m? So I can call this m, you know, whichever one I want to do, my m2 is equal to the m1. This is not the slope-intercept form. I need to write it in y is equal to mx plus b, okay? So here, plus 3x on both sides. Now I know what my slope is, that's 3, and now I can write the equation. So I'm going to start out, I'm just going to go directly to 3x plus b. Here I knew what the b was. This is parallel, so my intercept's going to change, but I knew it had to go through that point. So again, directly, here's my y, my x. 2 is equal to 3, negative 1. y1, x1 plus b. And then I just solve for that b. Minus 3 plus b, and then I'm going to add 3 to both sides. I'm going to write it over this side. So b is equal to my 5. And then I finish it up. Y is equal to 3x, has the same slope, and now it goes to a different intercept because I've slid that line 2 different places. Okay, so I want to go to Desmos real quick and graph those out. Let me kind of pull up something here. Go to Desmos. Okay, and now I'm just going to type in the 2 equations. So we started out with y is equal to, once I put the minus 3x into correct form, that was the 3x plus 4. There's my first line. Let me slide this over here so we can see. And then I want to do the second one, y is equal to 3x plus 5. Did I finish that one out? No, y is equal to 3x plus 5. these two lines are parallel, but they have different intercepts. So right there, that was the 0, 4, and this one's going to be the 0, 0, 5. Okay. All right. So let me get rid of our graphing calculator. Let me pull this away. We may use this again later. I'm going to erase this. So write an equation of the line passing through the point negative 3, 2 and parallel to the line defined by x plus 3y is equal to 6. So very similar to what we had last time, negative 3, 2, and then parallel to, so parallel, I need to go through here, x plus 3y is equal to 6. Does this pass through there? So if I took this, is this a solution to this? So if I put x plus 3 times y, does it come up to 6? So my x does negative 3 plus 3 times my y is 2. Does that equal to 6? Is that a solution of that? So negative 3 plus 6, does that equal to 6? No, 3 does not equal to 6. So this, certainly an equation of a line, but it doesn't go through that point, okay? So the first thing we want to do is convert this into its slope-intercept, okay? So I need to get that into there. So I need to solve for y. Okay, so minus x to get us started. So 3y is equal to 6 minus x. And then I want to divide everything by 3. And I'm going to write this first. So this is this divided by 3 and that into 3. So minus x over 3, or minus 1/3 x, very same thing, plus 2 when I get to that one. Okay. So my slope, my M1 is negative 1/3. That's what that is. The negative 1/3. Okay. So I'm going to go over here and I'm going to do the very same thing. So I'm going to say y is minus 1/3 x plus b. And then I'm going to use this form for there, okay? So I'm going to make it fit by changing this b. Tell me what the b is. That'll have this, that will go through that point. Well, that has to satisfy y, the 2. Same thing we did over there that it didn't work. The x is negative 3 plus my b, and then I just saw 2. This is plus 1. The 3's cancel out. That gives you plus 1 plus b. And again, I'm solving for b, so minus 1 minus 1. That my b is equal to 1. And then I just finish that up. Y is equal to minus 1/3 times x plus 1. So here it says, give the equation of a line. So find the equation of a line that passes through this point 6, 8 and is perpendicular to the line defined by 2y plus 5x is equal to 10. Okay. So 6, 8, and it needs to be perpendicular to 2y plus 5x is equal to 10. Now, for this one, when I did the parallel lines, there was no way that I could pick a point and have something perpendicular at the same time. When I'm doing perpendicular lines, they could pass through the same point. It could be that point and there could be perpendicular, okay? Or I could be given here perpendicular to this line and I could be given that point, okay? But this point could be on here. When I did parallel lines, there was no way that I could say, here's this point and here's this point. It would be the very same line. If it went through that point, it's got to be the same line. Okay, so two different points, or they're going to be the very same line. Okay. So again, I've got to find my M1, and the only way I can do this is to write it out in slope-intercept. So I want to solve for y. So minus 5x minus 5x, 2y is equal to 10 minus 5x, divide by 2, and this is 5 minus 5 halves x. And in standard form like this, I just switch these around, minus 5 halves x plus 5. So this is really y1 with slope m1, okay? So now I need to do, this is my m1, but I need something perpendicular. So I know for perpendicular, it has to be the negative reciprocal of that. So m2 would be negative 1 over my negative 5 halves. And if I invert and multiply, that should just come up with the 2/5, the negative reciprocal. Okay? And then I get to use my equation. Okay, so I know y is equal to mx plus b. This is now going to be my 2/5. And it has to go through here. So here's my xy. 8 is equal to 2/5 6 plus b. And then 8, 12/5 plus b, and then minus 12/5 from both sides, 8 minus 12/5 plus b, and this is over 1, so I need to convert that over, so that's 40 minus 12 over 5, and then that would be what, 28 over 5. So then I just put this in for the big plus, 28 over 5. So let's do one more of these, and then we'll kind of move over into some applications. One 6x plus 3, okay? So it needs to be, I need a line that's perpendicular to that one, perpendicular to y1, this is kind of like a y1, perpendicular to that and goes through negative 8, 4. Okay. So my m1 is 1/6. So my m2 would be negative 1 over m1, which is 1/6. Invert and multiply. So m2 would be negative 6. Sounds right. And then it just needs to go to that point. So y is equal to negative 6 plus b, negative 6x plus b. My y is 4, negative 6, negative 8 plus b, and then I just solve for b. 48 plus b, so minus 48, and then our b is minus 44. So then we just finish this up right here. Okay, so that says that y is equal to 6x minus my minus 44, like that. Okay, so here's some application, and this is our kind of business applications for this one. And it says the local hardware store charges $28 to rent a carpet cleaning machine for 24 hours and $10.98 for each medium-sized bottle of rug shampoo. Write a linear function S that represents the cost of renting a machine for X days along with 2 bottles of rug shampoo, and then evaluate S of 2 and interpret the meaning in terms of, in the context of the problem. Okay, what does it mean in terms of what you would cost? Okay. Okay, so we're going to do this. This is X days. Okay, so we got that. And then here's what we're going to do. So let's say the local hardware store charges $28 to rent a carpet cleaning machine for 24 hours. Okay. So I'm going to do, here is my first. So in X hours, so S is a function of X. I'm going to write some linear function. And then $28 times, I'm just going to write it 28x for 24 hours. So this is 1 day. Okay. Plus $10.98. So this is, let me kind of write it out this way. 28x, that's going to be for a carpet cleaning machine, and then $10.98 for each medium-sized bottle of rug shampoo. Okay, so plus yes, so let me kind of hold on. Let's leave that alone for the second, because this is going to be plus 1098 times the number of bottles for each medium-sized bottle of rug shampoo. Okay. So this is kind of a little different, because I'm going to say, well, how many bottles of the rug shampoo? And then here's the number of days. So this is really in 2 terms. So I'm just going to use just S, because it is in terms of X, but I got to do my B first. Okay. So now it says write a linear function S that represents the cost of renting the machine for X days along with 2 bottles of rug. So now we know what the B is, our S of X, because now we've reduced it down just to X. 28x plus 1098 times our 2. Okay. If I hit my calculator on that, this is just going to be 2196. Okay. So that's our calculator. Once we know this, we just say, well, tell me how many days you're going to do this. You got 2 bottles. I've got that figured out. Now your total cost, the sum of these 2 things, is going to be based on how long you're going to do this. And it says evaluate S of 2. S of 2 is anywhere I see the X, I put that, my 2. This was a function of the number of bottles, really. Okay, so here, this evaluated would be my 28 times 2 plus my 2196, 7796, and then plus tax. That's what you owe. Okay, and then interpret the meaning of the context of the problem. That's what you charge before taxes for renting the machine for 2 days, and you've also bought 2 medium-sized bottles of rug shampoo. So a speeding ticket is $100 plus $5 for every 1 mile per hour over the speed limit. Okay? And you're going to write a function that all you have to do is just tell me how many miles per hour over the speed limit they were, and this is what you write, here's what's going to cost you for that speeding ticket. Okay, and this is going to be a common concept that we're going to see as we build these things out. Okay, so your speeding ticket is $100. So if you got caught speeding, there it is, and then plus $5 over every one mile per hour over. Okay. So write a linear function to model the cost S sub x in dollars of a speeding ticket for a person cost driving X miles an hour over the speeding limit. So here is straightforward. You would just say, well, if you were over ever how many miles an hour you were over 2 miles an hour, you charge your extra this, and then whatever that base thing is for the 100. Okay, and then you would go up. So this is the mx plus b. Okay. Evaluate S sub 15. Well, it would be you were 15 miles over. You got $5 for every 15 plus your 100. And then that would be it would cost you $175. So we really need to kind of write this plus $100, kind of like that. Okay. Now, I could also do a similar function to this where the cost would be based on your miles per hour. Okay. So this is assuming where m is greater than the speed limit. Okay. This is your rate greater than. And here's what I would have to do is I would have to know what the speed limit was. So let's say if we were at 55, I would do the very same thing here. I would say $5, but I've got my m or my x minus the 55. This would give me above. So if you were running at 60 miles an hour, this would be the 5 miles above. And if it was the 15, so you would be at 55, you would be running 70. The 70 minus 55 would give you the 15 times this, and then still this would be the 100. Okay, so you could build a specific one based on that. And that kind of resets it up to looking like this. So linear functions for modeling business. Usually what you are, there's certain things that you want to break out, okay, when you're doing modeling business. Okay. The first thing is your cost, right? This is your cost function. Okay. The cost function looks like this. This is your variable cost times X. So this is per unit cost. And then plus your fixed cost. Okay. That's what in general a cost function looks like. Okay. If it costs you $3 per unit, this would be 3x. And then your fixed cost, and this is all your overhead, your rent, your lights, phone, all of those things. They're not going to change depending on this. The variable cost includes just those things as you go up, okay? So that's your cost. This, by writing it by itself, you can analyze where your cost lies, okay? And then you've got your revenue. Usually used R for revenue. This is your, so now we're into the revenue function. and your revenue is just what you charge. This is just, ever how much you charge times X, or you sell. Okay, so you sell 10 items, you sell them for $20 a piece, that's your revenue. Okay, and naturally now you're going to have some sales and all that stuff, but you want your base thing to kind of set everything. Okay, so this is the basic thing that looks for there. Okay, the most important thing as a business, you're looking at making a profit. Okay, now hopefully you make a profit. If you can just break even, if you can bring in what you make, here is, so your fixed could be your salary. Here's all the salaries for like a 40-hour work week. You can include these into your costs. And as long as you make enough revenue to match your cost, you're covered, you're good. But it's nice to make a profit, and that goes into your savings, right? Savings. And then over the long run, you're hoping to show, look, bank, I'm making a profit. I'm putting this money over here. I would like to expand. I think I could make some more money if I do use this equipment. I need to borrow some money. I'm making a profit off of my business. Okay. The profit function looks like P of X. C of X cost, your revenue, and your profit that you made is basically your revenue, your income, minus your cost. Okay. The break even is when you have no profit, but when you set this equal to 0, bring this over there, that means your cost is the same as your revenue. Okay, that's what that means. So all of the things that kind of sneak in on you. When's your break even? When do you make a profit of a certain amount? All of those things can be built into these business application problems. Okay. So Alina is starting a summer business power washing home driveways and sidewalks. She will charge $35 to pressure clean a driveway and the sidewalk in front of a house. Her startup cost includes her initial purchase of a power washer for $330 and a fee of $2 per house she must pay to the homeowners association for the use of the water for each house. Okay. Write a linear cost function for power washing at X homes. Okay. Okay, that was her fixed cost. So it says cost function. So her cost function looks like, so it will cost her $2 for each house she must pay to the homeowners association for the use of the water. Okay, so she must pay $2 times X number of homes. Okay, but then she's got her original cost of $330. Okay, so she's just opening up her business. This was her fixed cost. Here was an additional cost for each one. Okay, so that's her cost function. Write a revenue function. So her revenue, she will charge $35 to pressure clean a driveway and the sidewalk in front of a house. So she's charging $35 for each house, right? And so this is $35. If she cleaned one house, she would make $35, 2, 70, 3, what is that, 95, 105. Okay. So that's her revenue function. Now we need a profit function. And we just have to recognize we want to make this being positive corresponding to revenue. So we want this to match up. When our revenue is greater than our cost, we've made a profit. Okay. Okay, so this is our revenue 35x minus, and this gets subtracted off from everything, 2x plus 330. Okay. So then I just, group this out, minus 2x minus 330. So out of this, per unit, 33x, and then minus 330. Okay, so that's our profit function. Tell me how many houses. Tell me how many houses, and we'll see if she's made a profit. If she's only done one house, she's actually still in the hole. Okay, so she needs to do a number of houses before she's made a profit. Okay, and it's asking us, well, what does that look like when she's done 15? 33 times 15 minus my 330. So this is a positive number, $165. So that means she has done that. She has overcome this, and now she's made $165. So she's overcome her startup costs. Now, this is like a one-time thing. This is usually like a monthly, so you have monthly fees that you have to come up with, and sometimes if you had some initial fixed costs, you may amortize that over so many years or something. And again, you may say, here, I want to know when this comes over, but you can have several different versions of just monthly cost, monthly revenues type things, or a long-term, before you actually break even and get to those. So we still got our profit function. I'm going to slide this over. So P of X was 33X minus 330. And our last question asks us, how many homes must Alina power wash to make 330? So I want to know how many of these units how many houses or units do we need to produce to get P of X to be $330. Okay, so I'm just going to use this and then solve for X. So my 330 is my profit. 33 times my X, I don't know what my X is, minus 330. So I made 330 profit, add that to both sides. That goes out. So 660 is equal to 33x divided by 33, and then I get what, 20 is x. So I must do 20 homes to have, passed my initial, and then I've made a profit of $330. So if we graph that, that's basically what this thing looks like. And here would be our break-even point when our revenue, we start out down here. We wouldn't start negative. We would be like right here because we haven't sold anything. So that would be the difference. And as soon as I start making revenue, I'm subtracting off. So it's negative, negative, negative. Once I'm here, I've got a greater revenue than cost, and I've actually started making a profit off of there from the graph. That's interpreting the graph. This is your break-even point when they're the same. Here, I don't have this one. So suppose that Y represents the average consumer spending on television services per year in dollars, and that X represents the number of years since 2004. Use the data points 2, 308, and 6408 to write a linear equation relation Y to X. Okay, so I've got the television services, and that here represents the number of years since 2004. So 2 would be representing 2006. And then this would be 2010. So we have a base year that we started this, and here's the spending. Okay. So let's write a linear relationship between the two. Y is equal to mx plus b. That's what I want. This is my relationship. And I'm going to use 2, 308, 6, 408. I need to get my slope. I've got 2 points, so let's get my slope. This is y1, this is y1, y2, x1, x2, 0.1, 0.2, 408 minus 308. Okay, there's my y2, y1, x2, y1. So that's 100 over 4, and that would be just 25. Okay, that would be 100 over 4, which is 25. And then I'm going to let's pick out the smallest numbers. So let's do y is equal to 25x plus b. Y was, let's do 308, is equal to 35 times 2 plus b. And then minus 70 from both sides. So this would be, what, 238? Yep, 238 is equal to my b. So my linear function, f of x, I'm going to use notation, functional notation, is 25x plus 238. Interpret the meaning of the slope in the context of this problem. So this would be that the consumer spending has increased on average. This is in dollars. So this would be for every year it increased $25. $25 increase per year. Okay. 1 year it increased 25. So that's a per unit per year. Okay. So that's the slope, the meaning of the context. That's the slope is 25 for every 1 over. We go 25 up, 1 over, 25 up. In terms of the context, for every year, which is 1 over, we go up $25 spending. And then use the model from Part A to estimate the average consumer spending on television services for the year 2007. Okay, so for 2007, the only thing that we have to make sure of is that we remember base year, okay? So base year was 2004. How many years past that? 2007 minus 2004. That would be 3. So our x would be 3 to use this function, okay? So back over, f of 3 would be 25 times 3 plus 238, 75 plus 238. And that would be $313 would be the average spending in 2007. Okay. So I think that finishes up where we need to go from here. I'm going to hold off on some others and we'll work some others in class.